Cancer does not discriminate. Rich or poor, young or old, cancer is able to devastate lives. Some have already experienced it or experienced the loss of a loved one from it. For the victim that is developing the disease, they will suffer through excruciating physical pain. They are faced with a harsh reality that they do not have much time left on earth. Their condition will also affect their friends and family. The impending death of a loved one will cause anguish, and the slim chance of recovery will lead to hopelessness. But what if there is a therapy that can cure cancer with a high success rate? What technology needs to be developed to do so? Genetic engineering is a very appealing answer. Gene therapy has been in progress for years, and in 2017, the first gene therapy method was approved by America by the Food and Drug Administration, or the FDA. Gene therapy has proven to be a reliable method to treat leukemia, which is a blood cancer. With this, many are curious about how far genetic engineering can accomplish and how far we can take this new technology to save lives. Hence, research for genetic engineering should be prioritized over other therapy methods, as the benefits that it will bring is extremely beneficial to them in the medical field. Essentially, genetic engineering means to adjust or alter the genetic code of the cell, with the genetic code being the sequence of DNA that is responsible for the production of a certain protein. This can be done to specific cells in the human anatomy to determine what we want that cell to do. In the example of leukemia, an immune system cell is first extracted from the patient. The genetic code of the cell is then altered to target the leukemia cells. The immune system cell is then transfused back into the host. Other therapy methods to treat leukemia exist, such as a bone marrow transplant, and the combination of gene therapy and bone marrow transplant might just be able to treat HIV. But the results from experiments, while they are promising, are still not viable to use in medical therapy. The first use of a gene therapy method was conducted in April of 2015. Researchers in China first tried to use CRISPR, which is a genetic engineering method, to treat beta thalassemia, a potentially fatal blood disorder. They performed this experiment on non-viable embryos, which are embryos that are confirmed to have no chance of living. Their use of embryos, although they are non-viable, sparked controversy among journalists and scientists alike. Many claim that such experiments were immoral, as using any sort of embryos in experiments are considered unethical. Debates regarding whether or not embryos are considered as human life are just one of the many heated arguments that bioethicists have to make. Even more of this controversy comes from its results. Out of the 86 embryos that were tested, only a few of them resulted with a satisfactory result. The low success rate shows us that genetic engineering is very risky, or at least this method is. The fact that leukemia can be treated shows us that genetic engineering is viable if done correctly. Regardless, while gene therapy is able to treat genetic defects as it stands currently, it is only able to treat a few diseases. Single gene disorders are amongst the most well understood gene mutations. This is due to their simple inheritance patterns and causes of the disorder. An example of single gene disorder is sickle cell anemia, where the red blood cells of the host break down and leave the host with a shortage of red blood cells. This disease, too, is treatable via genetic engineering. However, the reality is that a majority of genetic defects are polygenic, meaning that multiple genes are responsible for the disorder. Disorders such as Down syndrome, Alzheimer's, and diabetes are all polygenic disorders. The best method to treat these types of genetic defects is to modify the host while he or she is still an embryo. This is because the structure of an embryo is much less complex than that of an adult. Even as a child, there are already multitudes of different cells that serve their own purpose. But during the embryonic phase, these cells have not yet differentiated into their specific cells. These cells are called stem cells, and they are the primary focus of gene therapy experiments. The primary concern for gene therapy experiments is the source of these stem cells used in the experiments. The most common and well-known way to retrieve these stem cells are from embryos. However, the chances of the embryo to survive after extracting the stem cells are slim. It is because of this that experiments on genetic engineering are frowned upon. For us Christians, we believe that human life begins at conception. By this belief, we would assume that the destruction of human embryos is considered as murder. But this is not the only source of stem cells. Another source of stem cells are umbilical cord stem cells, or UCMS for short. Compared to embryonic stem cells, these cells are much more limited and aren't as flexible as their embryonic counterpart. Nevertheless, these cells can act as a solid foundation for gene therapy, and it does not involve the destruction of any embryos. Experiments related to the use of UCMS have shown the safety and usability of this method in gene therapy. Before gene therapy actually takes place, parents have the option to examine their child to check for any abnormalities. As of now, examining their child is extremely stressful and ill-advised, because if the child is unfortunate enough to develop a certain genetic defect, nothing can be done to save the child. No current method is able to completely prevent the symptoms that come with the genetic defect. The parents are given the option to abort the child or to continue with the child's birth, knowing full well they will face the burden of raising a child with the genetic defects. But genetic engineering could save the parents from such dilemmas. It is true that birth defects are quite rare. Approximately only 1 out of 150 births result in a birth defect. Yet, if we consider the entire human population in this ratio, around 53 million people are living without genetic defects. Some of these disorders are fatal, such as heart defects, while others are bearable, such as Down syndrome. Gene therapy can cure any sort of genetic defect, regardless if it is fatal or not, since it is able to eliminate the root cause of the disease. By eliminating the root cause of cancer and disorders, gene therapy is much more flexible and could be used for a broader range of treatments. In theory, gene editing would allow us to edit every living thing to our benefit. Various microorganisms never before used in medical therapy could be adjusted genetically to create new vaccines, or to directly edit the malfunctioning gene. Furthermore, not only does genetic engineering grant treatment to currently untreatable diseases, but it may assist current medical therapies or replace them entirely. The number of cases for leukemia in America in 2019 is over 61,000, and a third of these cases were reported deaths. In Indonesia, there were nearly 350,000 people affected in 2018, and over 200,000 of those cases were reported deaths. This means that around 3 out of every 5 cases of leukemia result in death. Keep in mind that even with all these treatments available, the survival rate for leukemia are still fairly low. Gene therapy may drastically increase the survival rate of not only leukemia, but also other cancers and inherent genetic defects that one may develop. The ability to treat a broader range of diseases and genetic defects does much more than to only save lives. As it stands currently, disorders with low survival rates are merely treated with therapies that only suppress the symptoms of the defect. Although the patient may feel healthy, their condition still lingers. The friends and family of the patient are fully aware of this, yet they continually transfer payment to keep the therapy going in hopes of a miracle that the victim may recover. Eventually, these families may run into debt or bankruptcy, creating even more stress and grief within their household. Gene therapy does not hold the same problem. Once a patient is treated via gene therapy, the root cause of a disease would be eliminated, and there would be no longer any need for constant payment. It is a preventive solution to the continuous problem that is cancer. The root cause of a defect could be embedded in a parent's genes, and the disorder could be passed on to his or her child. Genetic engineering can eliminate this. However, the ability to remove an inherent genetic defect is a double-edged sword. A mistake in adjusting the genome of the cell could lead to unintended harmful consequences. On the other hand, successfully treating an inherent genetic defect would completely erase the disease that has been plaguing the past generations. Then, While risks of gene therapy are greater, the benefits immensely outweigh the risks. For example, coarctation of the aorta is a birth defect that severely narrows the aorta of a heart. The narrow aorta cuts off blood flow to the lower half of the body, and the child with this defect would most likely have to routinely make visits to the doctor. The early years of the child's family would be filled with caution, fear, and anxiety, while the child is completely clueless about their condition. Every trip back from the doctor only ends in two ways. Either the child lives to see another day, or they don't. The family would do anything in their power to cure the child, but the most likely solution for the child's problem is a heart transplant, and unfortunately, not many people are willing to be a heart donor. With enough research, gene therapy would be a much more viable method to cure these genetic defects. Once the defective gene responsible for this defect is corrected, the child's family will no longer have to suffer through the stress and hardship of raising a child that is tormented with a genetic disorder. As for cancer treatments, chemotherapy is currently one of the most frequent treatments. The powerful chemicals used in chemotherapy target the rapidly growing cells in the body. This method makes it effective against cancer cells, as those cells multiply far more rapidly than regular cells. However, these chemicals may lead to long-term side effects such as heart problems, kidney problems, nerve damage, or even the risk of developing another cancer. From these reasons, we see that other therapy methods have its own risks, but they are commonplace methods to treat cancers. Yet, even chemotherapy is unable to treat some diseases. Compared with genetic engineering, gene therapy is much more potent to treat currently incurable diseases single-handedly. Ongoing gene therapy experiments have not yet been integrated with other medical therapy methods, and it has still shown some promise. If genetic engineering were to be integrated with other therapy methods, it would most definitely be able to treat a plethora of diseases. But genetic engineering also comes with its own share of downsides. Because of how potent genome editing is, it can be used for more problematic reasons. One of those reasons being the use of genetic engineering for enhancement therapy. Widely known as designer babies, those who undergo enhancement therapy do not actually have any diseases or disorders. Instead, they are genetically modified based on a request. This can mean a parent would want their child to look a certain way or to have enhanced physical capabilities to get a competitive edge in sports. While this may sound appealing at first, there are various problems that come along with it. We Christians believe in the image of God, and tampering with the human genome for cosmetic purposes is frowned upon. Enhancement therapy completely contradicts this teaching. The resources used for enhancement therapy could also be used for medical gene therapy. The risks that come with enhancement therapy would be far greater than medical gene therapy, as the effects of gene modification may affect generations of children. It is much more beneficial to adjust defective genes than to risk of life of many due to a single person's request. With these reasons in mind, it is clear that in comparison with gene therapy, enhancement therapy is not worth the investment. However, even without enhancement therapy developing, gene therapy still has its controversial problems. The risks of affecting future generations due to a mistake made in gene therapy are there, but this can be avoided by only editing certain cells. By modifying certain cells and avoiding other ones, we are able to prevent mistakes that may lead to a generation of children with a genetic defect. But to ensure there will be no mistakes in the actual therapy, experiments are required. These experiments are notorious for being controversial, which brings us to the elephant in the room. Is it really ethical to mass-produce embryos for gene therapy research? The short answer is no. We Christians believe that human life begins at conception, but potentially destroying human life for the sake of science is immoral. Albeit the embryos are destroyed for the greater good, we don't ultimately believe that the ends justify the means. Instead, we can use an alternative source for these experiments. As stated previously, UCMS are stem cells that are not derived from embryos. This method may allow us to gather enough knowledge of genetic patterns to utilize for gene therapy without having to destroy human life. In fact, gene therapy for leukemia utilized UCMS as the precursor research method. With this method, research on gene therapy may continue without the need of destroying a single embryo. All things considered, research for gene therapy should continue for its potential impact on the medical field. With enough research, gene therapy would undoubtedly save millions of lives. One of the leading causes of death is cancer. Genetic engineering can change that. At the very least, gene therapy can reduce the number of deaths due to cancer. As for the individuals that bear a genetic defect, although few, we should not overlook them. We are able to help those in need by advocating for genetic engineering, and future families will no longer have to experience the hardship for caring for their hospitalized child.